Okay, I'm back here, and hopefully you have given these two proofs a try. So if you haven't, please pause this video, and remember, math is not a spectator sport. You need to jump into the action. So give them a go. First of all, you should have followed the setup in my previous video, and then you were supposed to give them a try to proving two different theorems here that happen to be converses of each other. And when you're ready to kind of compare to what I have, then resume the video. Okay, and I didn't mention in my last video, I left an open-ended question here you can go back to with any remaining time that you have now or on a future day. What else do you think is true? Do you have another statement that you would like to prove? Because remember, a theorem is just a statement that is true that can be proven true, and that we will hopefully use at a later date. So you're allowed to come up with your own theorems too, which is kind of cool. Okay, so assuming that you have tried it, I'm trusting you. Don't let me down here. This is what I came up with, and let's kind of do a talk through rather than me rewrite the whole thing. I thought I would talk through what I have. Okay, and let's kind of, where we should be at with proofwriting is we should be able to draw specific conclusions. And I think most of you are doing a pretty good job with this, although the given statement is a little bit different here. I don't know that we've done one where we've been given lines perpendicular. So your definition of perpendicular lines does say two lines are perpendicular if and only if they intersect and form right angles. If you jump straight to the 90 degrees, I could see many of you jumping straight here. Go back and change your definition right now. Get out your definition paper and make sure your definition of perpendicular lines does not include 90 degrees. Okay, the way it should work is if lines are perpendicular, then they intersect to form right angles. So my direct conclusion is angle 1 and angle 2, or if we had a 3 and a 4, we could say any one of those angles is a right angle by definition of perpendicular lines. So again, I'm using this word. It's more of a symbol, but I'm using the definition, very much the procedure we've talked about for starting a proof and drawing a specific conclusion. Now, from there, we definitely can get to 90 degrees. I'm not disagreeing that we have 90 degrees. Now I'm using I've got another word here, and I'm going to use the definition of that to say if, excuse me, sorry, if angle 1 is a right angle, then the measure of angle 1 is 90 degrees. And likewise, if angle 2 is a right angle, then the measure of angle 2 equals 90 degrees. Notice I'm transitioning from angle 2 and angle 1 without the M to measure of angle 1 when I put the equal sign and I start to use numbers, measure of angle 2. Just a note on notation there. And this one should have come together nicely. We're trying to prove congruence. So congruence, when I think congruence, I think equal. If measure of angle 1 equals 90 and measure of angle 2 equals 90, let's put those two together. Measure of angle 1 and measure of angle 2 are equal to the same third thing, therefore equal to each other. That is my lovely transitive property that I told you should be your favorite property, if it's not already. Or you could do substitution property of equality there. I would take either one. And finally, if measure of angle 1 equals measure of angle 2, then angle 1 is indeed congruent to angle 2. That is your definition of congruent angles. Don't overuse that definition. I notice students tend to use that whenever they want to say angles are congruent and they don't know how they're congruent. So for instance, we might know angles are congruent by our vertical angles theorem, and students will just randomly start putting in definition of congruent angles. So make sure that you're following that if-then flow, and you have to have the measures equal to say they're congruent by that definition of congruent angles. Okay, otherwise, what ends up happening is it will become a justification for something you can't actually say, and you'll skip steps and use that as kind of a false reason. Okay, I do have a note to myself, and I'm reading this note was to remind me to mention this. Maybe some of you caught this. This is a cool part of where we're at right now, is we actually can save some time, save some space, and shorten our proofs by using some of our previous theorems. So what we could have done in this proof is, if we got steps 1 and 2, once we know angle 1 is a right angle and angle 2 is a right angle, we could have actually skipped steps 3 and 4 altogether, because if two angles are right, then it follows that they're congruent. By my reason would no longer be definition of congruent angles. My reason would be right angle theorem. So take a look at your blue paper. I can't switch screens right now because my the video program that I'm using does not allow me to do so. It's not going to go in order. So you take a look at your blue paper. Take a look at statement number 7. If angles are right, then they're always congruent. That's what we just used to get from step 2 to step 5. That would now be step 3. 3-step proof. So it only saved us 2 steps. But that is kind of a sweet use of that theorem, and it's always going to save you a couple steps when you use it. Okay? Not a right or wrong. Either one of those is a beautiful version of that proof. Okay, pause the video and digest that. If you need to make some adjustments to your proof, rethink anything, go for it, and then when you're ready to move on to the next one, resume the video. Okay, so we're ready for the next one, the converse. And it's interesting to prove theorems and converses because sometimes they end up very similar, sometimes they don't. I grabbed exactly what was on your blue paper, and I'm going to go ahead and just put the proof on the screen so we can see that big and clear. Okay, so obviously starting with the given information here, angle 1 is congruent to angle 2, and the picture was also part of the given. So in the picture, we could tell that angle 1 and angle 2 formed a linear pair. So really, really, really important that we're picking up on step 3. So I'm skipping step 2 just for a sec, and I'll come back to that. But take a look at step 3. This is a pattern that you're going to use a lot, and we haven't gotten very used to yet. We struggled a bit the other day, and I think you guys started to make sense of it. I need to get the fact that angle 1 and angle 2 are supplementary into my proof, because that's going to allow me to make an equation that I can then flow from there with for the rest of the proof. Okay, the only way you know that those 2 angles are supplementary, I did not tell you that. That was not in our given information. The only way you know that is because at this point, you can recognize a linear pair from a picture, and you know that a linear pair forms supplementary angles. So that is my linear pair theorem. Again, go to your blue sheet right now. Yep, I'm waiting. Okay, take a look at statement 5. If 2 angles form a linear pair, then they are supplementary. So, if they form a linear pair, that's in your picture. Then, conclusion right here, angle 1 and angle 2 are supplementary by your linear pair theorem. Okay? So, if we get those 2 pieces, that's a really good setup for us. And I'm going to flow from there. So, if angle 1 and angle 2 are supplementary, then measure of angle 1 plus measure of angle 2 equals 180 degrees. I'm sure you had that in your proof at some point. Might need to adjust some reasons there if you jump straight to that and didn't use that linear pair theorem. So, should always be definition of supplementary angles when you're using that 180 degrees. And then this one's a little bit tricky to get to the end. I'm actually going to talk it through by using, by working from the bottom up. So, if we want to prove lines are perpendicular, I'm down here, step 9, and that's what I was asked to prove. One way I like to think of this is what would I need to know in order to know lines are perpendicular? Well, definition of perpendicular lines says 2 lines are perpendicular if and only if they intersect to form right angles. Not 90 degrees, right angles. We fixed that in the last one if we needed to fix our definition. So you might have made the same mistake if you did have 90 degrees right to perpendicular. So I want to try to get that angle 1 or angle 2 or any of those angles there is a right angle. So if I can get that, then I would be convinced lines are perpendicular by definition of perpendicular lines. Now, how do I know I have a right angle? I'm working my way backwards. If measure of angle 1 equals 90 degrees, then I would know angle 1 is a right angle. And now I've gotten to something that's sort of like a goal of, okay, I'm right here. Oops, measure of angle 1 plus measure of angle 2 equals 180 degrees. I want to get to measure of angle 1 equals 90 degrees. And in your brains right now, I know exactly what's happening because I read minds. What's happening is your brain is seeing 180 degrees and saying, hey, wait, 180 degrees. I can get to 90 degrees by dividing by 2, which is true. But then I would have to divide by 2 on the left side. And right now, if I divide by 2, I'm going to get measure of angle 1 divided by 2 and measure of angle 2 divided by 2. and that's gross. I don't know what to do with that. So if I want to end up with measure of angle 1, then I had to start with 2 times the measure of angle 1, so that when I divide, I get just the measure of angle 1. So the right side's looking real good. That 180 is going to lead right to that 90. I need to get 2 times the measure of angle 1 on the left, which meant I should have had measure of angle 1 plus measure of angle 1, and I can get that by a simple substitution. Okay. A lot of students struggle with working backwards, but I really think that's kind of one of the best ways to approach these, and maybe that made a lot of sense if you got stuck somewhere or skipped some steps, is a lot of times what happens. Students know where they're trying to get to and just do a little bit of a logic jump there. So follow through from the beginning. If you need to go back to it, the measure of angle 2 I replaced with measure of angle 1. That's my substitution property. That takes me back to, why did I do step 2 that I skipped here? Technically, I needed to know measure of angle 1 equals measure of angle 2 to make that substitution. And if the angles are congruent, then I do know they're equal from step 1 to step 2, but I needed to state that. So if that's true and step 4 is true, then it follows that I can make that substitution. Okay, so read it through the right way. Just make sure you follow the properties. This is very, very, very similar to a proof that we did together, or that you guys tried and then we talked about the other day. And I'm wondering if any of you picked up on that. Yes, if you're thinking number 8, the congruent plus supplementary equals right theorem, you're 100% correct. We had almost the same flow here, which means usually if you're repeating a flow, that means you could have referenced a theorem and it could have saved you a bunch of steps. You ready for it? It's going to make some of you really mad. If 2 angles, I'm reading statement 8, you're on your blue paper right now looking with me. If 2 angles are congruent and supplementary, wait a second, angle 1 and angle 2 are congruent, angle 1 and angle 2 are supplementary, then theorem 8, we proved it, congruent plus supplementary equals right. We know each angle is a right angle. Isn't that what I stated right here? So, follow the yellow. If angle 1 and angle 2 are congruent and angle 1 and angle 2 are supplementary, then I could have skipped steps 4, 5, 6, and 7. Actually, I could have skipped step 2 also because I wasn't using the algebra, and I could have gone straight to angle 1 is a right angle by not definition of right angle. Now my reason would have referenced that theorem, congruent plus supplementary equals right theorem. Remember, zip file. I'm referencing everything that I did previously and pretty much just repeated in this proof. And I don't need to repeat. I would have still needed that last step. So if you're looking for a nice, short, sweet version of what does that look like without all the scribbles, here it is in nice form. So there's my short, sweet conclusion with my theorem. And then, like I said, I did still need to follow that up at the end with if my angles are right angles, then the lines are perpendicular, definition of perpendicular lines. And a lot of you stopped one step before that the other day. I think we were trying to prove something as a right angle. You stopped to 90 degrees. So if you stopped once you had the right angles, you got the idea. Just remember, we got to get to the conclusion. Okay, signing off. I think that was a fantastic exercise in where are we at with proof writing. So don't beat yourself up if you didn't get a perfect proof. Hopefully you learned something. Hopefully that made a little bit of sense. If you have questions that I didn't answer in the video, write them down so you can ask me. And you don't forget them, because any questions are good questions and will help you to make sense of this in the future. Thanks for your effort, and I will see you guys soon.